Okay, let's give you guys some practice. So work out the area underneath these parametric equations. So if you get a graph plotter and plot this, it will give you this curve. So work out the area above the x-axis. So you're going to have to determine the interval yourself. Okay, you're going to have to determine these 2 points yourself. Okay, so work out the area here. So press pause and have a go. Okay, so to do this, you really want to sum up all the rectangles. So it's really you. So the area is really you summing up all the rectangles. Well, if you look at as you're summing up all the rectangles, let's just look at this random rectangle here. You're going to need to know the height. Well, the height is y, and the thickness. You need to know the thickness, dx. The thickness associated with this rectangle is dx. But because we're working in terms of time, we're going to need to abandon this. So because we're working in terms of time, we are going to need to work out the integral. So we're going to sum up all the rectangles here. Well, each step of the way, we're going to need to know the height. Well, when we're working in terms of well, the height will be given by this, because this is the height. So when we're working in terms of time, so the area is really us summing up all the rectangles. It's really us summing up all the rectangles. So each step of the way, we're going to need to know the height. Well, the height here is given by this. So it's really us obtaining the height, which would be this. And then we need to obtain the thickness associated with this. But the thing is, when we're working in parametric equations, we are working in terms of time. So a small change. Let's say at the moment the time is here, and then the next minute the time is here. So a small change in time, a small dt. How would that relate to the small change in the x direction? How would that relate to the dx? Well, in this case, we would look at this here. Differentiate both sides. So that would then give us dx equals dt. So in this case, a small change in dt would result in a small change in dx. Is a direct relationship. So just because it's in this particular scenario here, dx equals dt. So we can put this. Earlier was a equals y dx. Well, this here is your y. Each step of the way, this is your y. And then now the dx. Well, the relationship dx equals dt in this case. So we can put this into here. Well, we can put this into here. So that would be dt. So now we need to integrate it from where to where. Well, we need to integrate it from here. So in terms of time, it's going to do this from here, from negative infinity to positive infinity. But what time will it be when the y value will be 0? And then again, what time will it be when the y value equals 0 again? So to obtain this, so this relates to this bit here, and this relates to this. So what time will it be when y equals 0? Well, we would need to look at this. We would need to look at this. So set that to 0. So y equals 0. So set that to be 0 plus 2, and then add t squared, and then square root. So t is positive root negative root 2. So this here is negative root 2. This here is positive root 2. So our interval would be from negative root 2 to positive root 2. So us finding out the area here is really us evaluating this integral here. So the area is really given by this. So now integrate it, blah blah, integrate it, and it should be approximately this. Okay.